Assalamualaikum and good day everyone. Today we will learn on chapter 7, moment procedures. So before this, we already learned on how to determine the entry and the exit age. So now we want to estimate the number of deaths within the interval. So when we talk about expected number of deaths in the interval, so the notation would be E, the expected value for estimation, E dx. So dx is the number of death in the interval. And then another one is number of actual death in the age of interval. So for the first one is the expected number, the second one is the actual number. So the notation is dx. So both within the interval. So this one dx, so there is no number in front here, so we assume as 1. So the interval would be x to x plus 1. And then before this, in chapter 6, we already learned to estimate the number of deaths within the interval x and x plus 1. So we're comparing both for the expected number and the actual number in terms of one interval. So when we talk about moment, so you can imagine that the notation would be including the E. So the first moment would be EX, second moment will be EX squared. So you're already familiar with that notation. Moment estimation in a single decrement environment. So single decrement is for death. So last chapter we learned on double decrement, whereby the first decrement is all about death and the second one is about withdrawal. But in chapter 7 we just focus on the death, for the decrement for death. So there are some assumptions that we have to make for this estimation. So we have to know the observation period, date of birth, date of death. So recall RI and SI. So for this case, RI and SI should be in the interval of x and x plus 1. So RI and SI would be in between the interval. So the probability of death within the interval given alive at age x plus RI. So this person must survive until x plus RI. So this is the condition given alive at age x plus RI. So the basic moment function. The first one is you have to know what is nx. So nx is a total number of persons contribute to x plus 1. And second one is the expected number of death. So expected number of death you can find in the equation of 7.2, where expected number of death is the summation of the probability of death from x plus RI to TS minus SI minus RI. So if we draw the timeline, so within x to x plus 1, so x plus RI, x plus SI should be in between the interval. So the T between here, the t here, this is t. T is equal to x plus si minus x plus ri. So we get si minus ri. So t is si minus ri. So the current age is start from x plus ri. So the expected number of death for x is the probability of death from x plus ri to x plus si. So the t become si minus ri. So it's equal to the dx. Dx is the actual number of death. By using the approximation of this one. For fractional age, where the x is not in terms of integer, it can be 0.2 and t also can be 0.8, for example. So we call it as fractional age, and then we can use the approximation to calculate the qx. So this time we also use approximation to calculate the fractional age, because the x and the t not in term of integer. So the approximation we use this one. So si minus ri times qx. So the equation of 7.2 become 7.4. This is how we get the equation for 7.4. From that equation, we can calculate qx, which is equal to dx, the actual number of death, over the summation of si minus ri. So this is the general form of moment estimator in a single decrement environment. Okay, now let me show you one example. Let's say you are given the interval estimate x plus 1 is 20 to 21. First, we define whether the yi and the zi for each person are included in the estimate or not. So the first one is 19 to 20.5. So it includes in the interval estimate 20 to 21. So contribute. Person 2 also contribute, because at least there are some point that includes in 20 to 21. Person 3 also contribute. However, person 4 is not contributing in interval 20 to 21, because the entry age is at 21 and the exit age is 25.5. It joined the group after the interval, so it's not contribute. So number of people is contributing, and 20 is equal to only 1, 2, and 3. So nx or n20 is equal to 3. So first, we have to find the ri and si. And then ri, si become, so 19 is before 20. So ri is 0 and zi is 20.5. So x plus si is 0.5, and then this is 0.1, and 21.5 is more than 20, so we put 1 as si, and this one 20.2. So after the interval estimate 20, so 0.2 and 0.9. So total number of expected death is SI minus RI times QX. So we add one more column, SI minus RI. So this one becomes 0.5, 0.9, 0.7. So now we will get the summation of for all times Q20 is 2.1. So according to equation 7.5, Q20 is equal to D20 over 2.1. The denominator is, so this is the denominator. So now we will go to next section where the moment estimator for each special case. We have special case A, B, and C. So the denominator for each case is different. So for special case A, where the RI and the SI is 0 and 1, the moment estimator become dx over nx, because SI minus RI for the denominator become 1. And for special case B, where RI is between 0 and 1 and SI is 1, the moment estimator become one minus RI. And the last one for special case C, where RI and SI is 1 and SI is between 0 and 1, the moment estimator become SI. So the difference between each case is the denominator. Okay, let's try example 1. For the sample of 5 people whose basic data are given as below, estimate Q30 using an observation period of calendar year 2007. Estimate Q30 meaning that the interval estimate is from 30 to 31. First, we have to determine the YI and the ZI. Okay, first we draw the table. So we determine the YI and ZI. From the YI and ZI, we will get RI and SI. So the last column is SI minus RI. First one is 0.5, 0.75, 1, 0.5, and 0.25. So the total, the summation of SI-RI is 3.0. So now we draw the timeline. So person 4 from 29.5 until 30.5, the yi and zi. So person 2 until person 2 person 3 from 30 to 31, person 3 from 30 to 31. However, he died at 30.75. Person 4 from 30.5 to 31.5. So after the interval, somewhere here. And person 5 is from 30.75 until 31.75, but he died at 31.06, somewhere here. 31.06, somewhere here. He died. So person 5 died here, somewhere here, 31.06. So the interval is until 31. So the person that died within the interval 30 and 31 is only one person, which is person 3. Person 3 and person 5. However, person 5 died after the interval. 31.06. So we exclude the data of this for person 5 die. So we just take into account for person 3 because person 3 die within the interval of 30 and 31. So to find Q30 is equal to D30 over SI minus the total of SI minus RI. So we get 1. D30 number of death is 1 for person 3 over 3. So the total we get here for SI and RI is 3. So we substitute 3 here. So as moment estimator for Q30 is 1 over 3. Okay, now you can so next we go to exposure. So exposure is the denominator, which is the summation of SI minus RI. So before this, we are calculating schedule exposure. We call it as schedule exposure, which is the SI and RI. We do not take into account the date of death. So we take the date of the schedule date. So there are two kinds of exposure. We have schedule exposure and exact exposure. So schedule exposure, like the example 1, where SI minus RI follow the schedule, not the date of death. So exact exposure is like person 3, only person 3, person 3 is included in the interval estimate, die at 30.75. 2.75. So yi, zi is 30 and 31. So the difference here is 0.25. To get the total exact exposure is equal to scheduled exposure, which is 3, like in example 1, minus the difference 0.25. So the difference here 0.25. So we get 2.75 for total exact exposure. So meaning that total exact exposure, we take into account the date of death. So this is the difference between exact exposure and scheduled exposure. So in example 1 is scheduled exposure. In example 2 is how to find the exact exposure. So the difference is the scheduled exposure, we do not take into account the time, the time of death. We just follow the interval. So the exact exposure, we take into account the exact death. So the death happened here. So for exact exposure, we take ZI at SI at so for exact exposure, we take ZI at the time of death. For schedule, we take ZI at the X plus 1. So this for schedule and this for exact exposure. You can read by yourself the relationship with central death rate. And now we go to grouping. How to group according to the special case. So we just divide the grouping into two cases, special case B and special case C, because special case A is between interval 0 and 1. For special case B, where the Ri is between 0 and 1 and Si is 1, we denote it as Bx. So the Bx is a subset of Nx. So Nx is the number of people contributing in the observation. So the Bx, where the Ri is equal to 0. So the participant with Ri is equal to 0, we denote it as Bx. Like example 1. Example 1, if you look at example 1, the Ri and Si where is equal to 0, okay, in example 1, person 1, 2 and 3, the Ri is equal to 0. So for this example, the Bx for example 1, the Bx for example 1 is equal to 3. So Nx, the total contributing is 5 in example 1. So Kx is Nx minus Bx, which is 2. Kx where Ri is not equal to 0. So person 4 and person 5, Ri is not equal to 0. So Kx is for person 4 and person 5. Bx is person 1, person 2 and person 3. Special case C is for those with Ri is equal to 0 and Si is between 0 and 1. If in example 1, Cx is for those with Zi between 0 and 1. Si for person 1 and person 2 is between 0 and 1. So for example 1, the Cx is equal to 2. Person 1 and person 2. This is how we groups the participants according to the Ri and Si for which spatial case. Thank you.